Alright guys, we'll set up to do the PCD drilling and tapping for these bearing covers on the housing. So first thing I'm going to do is find the center. So we'll do the X coordinates and we'll do the Y coordinates, come up with a center point. I'm just going to use the edge finder for doing this. If this had to be split tight accurate, I'd use a dial indicator, little lever indicator to go around inside there, but just for the PCD holes, they're going to have clearance on the end covers anyway. So if you're out a couple of thou one way or the other, it's not going to be the end of the world. So we'll set it up with this edge finder first, get the center, and then we'll go through the process on the digital readout, how we go about setting up PCD positioning for holes. All right. 0 for that. Half that. Come across to 0. Up. We're doing the y-axis now. Tell you what, that bore on that one there came up within 0.005 of the bore diameter. So I'm happy with that. Right, so that should be our center point there. What I'll do is I'll reposition the camera up to the digi readout and we'll go through setting up a PCD. Righto, hopefully we can see this all right. So these are the holes in the end that we want to drill and tap for those end covers. So we've zeroed up our X and our Y on the table, and we're just going to select the PCD function on my particular DRO. That's that one there, and you can set the PCD in the X and Y direction. I'll change that if I've got a vertical. Pardon me, a horizontal head on here, and you're drilling in sideways. You'll change that orientation that the DRO is going to read off. Right, so that's what we want. So we'll enter that. The center position that we've already got, which is we've zeroed out. The circle diameter that we're working to on this one here is 50 millimeters. I'll enter that. The start angle. So in this particular case I do want to start at 0, but you can start anywhere around that PCD that you want. There are some unusual applications where I've done that, but in this particular case I want my holes top and bottom. So that is the 0 angle start point. So we'll select that. The end angle. Now the end angle is going to be 5 times 60, which is 300. That's for the last hole that has to be drilled. So I'll enter that. And the number of holes we're doing this is 6. I'll enter that. So that gives us our first position to move off to, which is in the X direction, which is in that direction. Of 25 millimeters, obviously, because the radius is 25, so the diameter is 50. So we'll come on down and we'll zoom down on that, and we'll start spotting those through, ready for that drilling and tapping. Righto, so we'll move off our first one, 25, and what I'll do is for the next one I'll show you what we're tapping on the digi readout. So I'll come back 25 until we get that zeroed out. Now these are going to be drilled and tapped for an M5, these blokes, so a little bit smaller. Alright, we'll come up to the digi readout and we'll go through what we're seeing. Right, so effectively we've done our first hole, so we're going to select the next hole. Oops, back the other way, which is just done hole number 1. Hole number 2 is giving us a new coordinate system to work to. So what we need to do, we need to zero out the X and the Y, and that positions us for the next hole. So we'll come back here. Oops. Forward 0, and I'll move the y-axis the other way until we hit 0. And that's ready for our next hole. So each and every hole that we do, we just press the down arrow. For hole 3, gives us a new coordinate system, which is 25 millimeters off center for the on the y-axis, on the x-axis, sorry. So we'll just keep working this around until we get our holes all done. We go to 4, so again 5, 6. Gone over, we'll go back to 1, we'll go back to 2, so that's the hole we're doing at the moment. Alright, we'll come back on down and we'll get that one out of the way. Alright, we'll do this one. Next hole. 25, directly across. 0. Alright, I'll change this drill out for a tapping drill now, and we'll repeat the process and come around and get those drilled out, and then we'll tap them, and then yeah, we'll flip it over and do the other side. Alright, I've got a drill in here that's sorry, a number drill I should say, in here, which is 4.2, which is the tapping size for an M5 metric thread. So I'm going to go 10 millimeters deep on these. I've got that little transition between that boss that we've welded in and the end plate. I don't want to break into that because I don't want oil that may migrate through those holes. So we'll keep these holes blind before we hit that weldment or that transition point. All right, so I'm going to go about 10 mil deep on these. Go back to our first hole. So once again, we'll work off our coordinates and our digital readout. So our y-axis will come back to 0. Our x-axis will come back to 0 as well. All right. must admit, since I put this doesn't always happen at the most inconvenient times. I was about to say, I must admit, since I've put this DRO on this machine, I don't think I've used the my rotary table dividing head to do any PCDs at all. I've done it all off the DRO, and it's dead smack accurate. All right, I'll set up and we'll get these tapped out, and we'll come back on the last one. Right, we're tapping the last one in now. Now if I did break a tap off inside here and I couldn't get it out, I've got a very good friend who's a retired tool maker. And he has the most magnificent shop, but he's got a little EDM machine with a tiny little probe stick that he can pop down and burn out broken taps and broken bolts and all sorts, broken drills, all sorts of things. As a matter of fact, I've got a good friend of mine, Ian, who's making an Offenhauser, a little engine, and he was doing the oil ways inside that particular crankshaft, and 3mm diamond, I think he was in about 50mm, and he snapped the thing off, and he's taken it around to Graham's, and he's put his little EDM stick on it and burned it out, and then he continued through and completed all the bores, all the angle bores for him, using the EDM, and that was a job that he was stressing about for months on how on earth he was going to do it. But, yeah, Graham had it knocked over in a day for him, with no issues, including getting out fixing the broken drill. All right, we're getting to depth now. Yeah, so one day I might try and get out there and show you what his workshop's like. He runs it fully on renewables, so he's got wind power, solar power, and he makes his own biofuel, his own biodiesel that he runs his backup generator on. And an absolutely amazing setup he's got, and a very, very clever man. All right, that's that done. We'll flip it over and we'll do the same on the other ball. Refer its cap, I'll deburr these and give it a quick stain and flip it over. Right, last hole on the side to do. I've gone up a number size 2 on the drill. I noticed on the other one there it was tending to drag a fair bit, rub. So coming up one size has certainly made a difference. You can still feel it working hard, but it's a lot easier. And there we are. You can see those shavings coming out, being ejected as it's being tapped in. So that's that done. I've got another couple of holes that I need to drill in here. I'm not going to do those just yet, but they're for the guard that goes over that timing belt. So I'll wait till I've got all this together and the guard fabricated up, and we'll see where those holes sit, and we'll mark them and drill them at the assembly, which is the way that I like to do guards. It's a lot easier once you've got the whole thing together to try and get your head around all the gotchas, and it's much easier to go and sketch up guards when you've got that assembly done. Alright, one more set of PCD holes to do, and they're the ones in the back for the main worm wheel housing. So I'll deburr these and we'll flip it over, and we'll get ready for that last drilling and topping, or that last PCD drilling and tapping. Alright guys, we're on to the last of the drilling, and what we're going to be doing today on this operation is on that back compensating ring we've got a series of 6M6 holes. It's an 82 PCD, so we're going to set that up to do those. What I thought, just to do it a little bit differently, I've orientated this so our first hole is going to be off 30 degrees, so we might just go through the DRO set up with an offset hole start. So we'll see how we go. So that's to hold the fasten this. What's a good view? A little bit hard to see, but this housing in the back here is going to bolt up onto that compensating ring. So this is the housing that has the shaft bearing sets for the worm wheel. That's up inside. So we'll get to that now. So the first thing we'll do, as always, is we'll find the centre, and then we'll come onto the DRO, and we'll get that PCD set up. Righto, we've got that zeroed up on the bore, so we'll set in our parameters now. Get the drawing so I know what I'm doing. Right, so we're going to go to our PCD function. So once again, we're on the XY axis for this unit. You can change that as you need to. So we're on 0, 0. Pitch circle diameter, this is going to be 82 millimeters. Confirm it. The start angle on this, we're going to kick off at 30 degrees. Confirm it. So the end angle is going to be 300 degrees plus 30, so 330 degrees. Confirm that. Number of holes, once again, is 6. So I'll enter that. That gives us our first position start. So I'll get a centre put into this chuck, and we'll get sorted out. Right, guys, we'll start doing the drilling these holes and tapping for this PCD on this compensating ring for the housing. I was lying back in bed, and it's funny, when I was machining this and I was copying that bad vibration, that's how things come back and how they sort of jog memories. And I had an experience going back 25 years now, I reckon, maybe more, of just that. And I was working for a company that we were doing a lot of work for a large multinational manufacturer, and on one of their big mills, and there was a process where they needed to do roll changes, and they needed to get from gauge to roll change position and then back to gauge again when the roll change is completed. And the process is 20 minutes each way, so it was 40 minutes, and they wanted to look at ways that they could decrease this time, because over a 12-month period it meant an awful lot in dollars in production. So there was a team put together to look at how we could go about increasing this speed, and the obvious one that kept coming to the table was to change the ratio on the worm and wheel, the primary worm and worm wheel. It did go through a number of breakdowns, but the primary set was the best option for us, and we could shave maybe 10 minutes each way, so that was 20 minutes we could shave out each way doing that. So I engaged a company called Car Gears, which was a wonderful gear manufacturing company just up the road from us, less than an hour away. A lot of old machinery, but it was really good stuff, and they could manufacture the most amazing types of gears that you could imagine. Very, very universal shop. Unfortunately out of business now. I was up there a couple of months ago, and walking across the paddock where that shed used to be, where that workshop used to be, and it was a very large workshop, and having a bit of a reminisce. And Car Gears, you guys in Australia may remember Fesca Car Gears, or Fesca Qualis gears. Well, the car in that Fesca Qualis is Fesca Qualis. Fesca Qualis is Car Gears, and I get it out of my mouth. So they've been around since the early 1900s, a very well established company, but just very sad to see a business like that go. They designed up a 5-star worm wheel that we could fit into place. So I'd given them all the specifications, and I'd done some preliminary drafting, some preliminary layouts for it, and they've gone ahead and manufactured it, and we've worked in very closely with our scheduling people to get everything down, each stage down to at least an hour. That's we could track our progress as we were going, so that if we were starting to fall behind, we could pick it up and work with some very, very good schedules, some very good planners in those days. So it was about 4 days to actually get this housing stripped off the top of this mill, and 90% of that work was rigging. And when you work with good rigging crews, it's really it's an absolute treat to watch guys and how they go about their job, and the thinking that goes behind it, and the way they square things up for the lifts to get it absolutely perfect. It's an absolute joy to watch. A good rigging crew can make or break you in jobs like that. So plan was I was going to knock off at 10 o'clock in the morning, and then head up to Car Gears at midnight to look at the assembly. So the plan was the housing would be taken up to Car Gears. They would assemble all the new worm wheels, all new bearings right through the whole show, basically a complete package, and then send it back for us to install. So I've rocked up to Car Gears, 2 o'clock in the morning. The old foreman, Bill Wright, wonderful old man, a lot of years, a lot of experience under his belt. What he didn't know about gears wasn't worth knowing. But I can remember the assembly being lowered into the housing, which is sitting upside down at this stage, and hearing a clunk, and looking at it, and looking at the worm wheel not fitting into the housing. And it's one of those horrible moments that you have where your heart just misses a beat and jumps up into your throat, and you draw breath. It's a horrid feeling, and I've scrambled for the set of drawings, and unfortunately the detail for that particular part of the housing was missing in my drawing set. So I've gone and phoned up one of my lead designers, James, and said, James, get out of bed, get to work as quick as you can, I need to confirm a dimension. So he's rocketed into work, and 45 minutes later he's come back and given me the number, and the new worm wheel should have cleared by at least half an inch. And I've had a close look at the housing, and where this machine out for this worm wheel had to be was about halfway in. So there's an awful lot of overhang on a boring bar to actually try and machine that out, and you could see massive vibration that was in that housing. And I reckon he's gone to his mate and said, what's got to fit inside here? And he's showing the worm wheel, which was quite a lot smaller than the one we were putting in. And it was originally a 2-start, and we were putting a 5-start on, so the diameter had grown quite a bit. And it's fitted, and he said, that's it, I'm stopping here. And 50 years later we've come to do the mod, and it's caught us out. So phone calls to transport companies to get low loaders back up inside. I've contacted one of the big heavy machine shops in my area, and organised for a crew to come in, gone through how I think we need to deal with this issue, and Damo was fantastic. And having that relationship, and I talk about having a relationship with your contractors, it's times like this that relationship really pays off. When you're in a hole and you've got no way out and you need help, to have that support by your contracting groups is absolutely amazing. And these guys pulled out every stop to get us out of strife. So we got the housing back to them. He's actually pre-machined or pre-flame cut out a big heavy lump of steel to actually bolt onto or clamp onto this housing, so we could actually do it as a full cut, because it was actually a half moon that was machined out of this housing where this worm wheel had to sit. So they've set it up in a big floor borer. They've machined it out, done a magnificent job. Back on the low loader, back up to Car Gears, installed the entire package, set all the backlashes, set up everything perfectly, back to site, and we've rebuilt the mill again. And the electrical engineers have gone in, done all their commissioning, all their checks, and we've handed it back to production, and it did exactly what it was supposed to do. So we did cut 20 minutes down on that roll change. But the project engineer that was assigned to this, you couldn't see him for love and money during those issues. He'd gone and stuck his head in the sand. And at the end of this, we always have a wrap-up meeting where we go through our learnings on what we could have done better on this. And I can remember going to this meeting, and this particular project engineer looking at me, and we walk in, and the first thing he's done is gone straight for the man, and he's blamed the chief mech designer for all the problems that occurred during this particular job. You know, these are things we should have envisaged, but You know, it's not every day you go and take 20-25 tonne off the top of the mill and pre-measure it before you go into the job. You do have to have some confidence in the drawings you're working to, but unfortunately you couldn't see that. And look, the time that we actually lost on this was just over 24 hours. I mean, it was an amazing job by everybody to actually pull this back. You know, the boys putting the mill back together again, pulled back time on us. It was just a really joy to be with and work with people like that. You know, everybody pulls together, except this one particular man at the top of the tree was the project engineer, and he's ranting and raving in this meeting about how this should have all been sussed out before this happened. This should have all been planned. Now it's everybody else's fault, and he was dismissed. So he did get his comeuppance. So I'd worked with this particular big manufacturing company for many years in the past, with other companies, and done a lot of work with them, and they knew what I was on about, and I think it soon came about what this guy was on about. And it's funny, the time and effort that some people put into setting up on what I call the pyramid of responsibility, where if something goes pear-shaped, it's always going to be somebody else's fault why that's happened. Unfortunately, this guy, for him, he hadn't set up his pyramid of responsibility. This is something that was totally unforeseen. There was nothing that was in a contract that could be written in for this. And rather than him taking any of the blame or any of the responsibility, he's blamed everyone else. And fortunately, the company that we were doing the work for saw through that, and he wasn't back on site ever again after that. So yeah, it's just funny. I saw that vibration there. It's funny how these little memories do come flooding back, and you think about things you've done in your history and your past employment. So maybe through these little jobs, I'll give some little anecdotes about my experiences, and there's certainly been an awful lot, a lot of stress, and certainly a lot of satisfaction too. So. I hope you don't mind me rambling on a little bit, but we'll get back to this very little tiny gearbox here, and we'll start cutting this PCD out. Alright, here I am ranting and raving about work history, and I've done this PCD right. It's not going to hurt. I wasn't thinking, probably too early in the morning, but yeah, I'm 30 degrees out. It's not going to matter. We'll leave them where they are. It's not going to affect the function of this in any way. So we'll go ahead with that little blue. Anyway, I often wonder whether it's worth talking about work history and experiences you've had, but look, if it's something that's hasn't got a place in this sort of forum, let me know in the comments, and we'll just stick to the machine. All right, let's get these drilled down to depth. We'll go 10 mil on these. Make it 9 mil. I'm going to try and stay away from that transition there, and we might have oil leaking in. Right, there, done. We'll set up for tapping. I'm gonna have to give myself the sack, I think. Too early in the morning. Well, I'll bring you back for these last two taps. I blame my lack of coffee for my little mistakes. Because I haven't got my coffee, it's because my wife hasn't brought it in. So I blame her for the mistakes. How's that for a pyramid of responsibility? Oh dear mate. I tell you, I love these little spiral taps. They do a great job with ejecting those chips out. Righto, we'll move on to the last hole. There we go. That's it. Down to depth. All complete. Here comes the rain. Alright. I do have the small hole, the drawn tap for the level indicator for the oil bar. I'll do that a bit later. I have a bit more to think about that. I'll deburr these, and I think that's all the machining complete now on this sort of housing. Apart from a couple, as I said, the level hole and a couple of holes needed to do for locating the guard. So what I think we'll move on with next is the housing that's going to fit into the back end of this. I'd like to try and get that together, and try the worm in there with some dummy bearings, and we'll see how that's looking. All right. Well, I'll get cleaned up here, and we'll get set up for our next elements.